Hello and welcome to Positive Physics. Today we are looking at smoothing an AC supply, so using a rectifier circuit with a capacitor. Now here we have a normal bulk standard AC supply, V0 being our peak voltage and the time period T being the time for one complete oscillation. So for our supply at home, V0 is approximately 320 volts. No, I haven't got that wrong. Remember, it's RMS, which is 230, which is the root mean squared value. But the period T comes from our frequency of our supply, which is 50 Hertz. So I'll let you work out what that time period is. Okay, so here we have a circuit for half-wave rectification. We have an input voltage, which is AC. We go through a diode, which only allows current in one direction. And then if we measure the output voltage over the resistor there, we will find that we get a half-wave rectification of our AC. So this is what this looks like. We have our zero value here. And effectively, because the diode only allows current to flow in one direction, we get the bottom part of this wave just chopped off, okay? Which is all right, except it's a bit bumpy. And some of the equipment that we use won't want to work with bumpy supply. It'll want a smoother, more even supply. So let's have a little look at what we can do. So that's using just a diode. That's probably what you saw maybe at GCSE. Now this is a rectifier circuit where we have the input voltage, AC, we have the diode still, we have our resistor. But in parallel with our resistor, we have a capacitor. And if we now look at the output rectifier voltage, we end up with this smoothed path here. Mine's a bit wiggly, I'm sorry, I couldn't draw it any smoother than that. But we end up with, so we've got this voltage increase from our supply, and then rather than just dropping down and nothing, it gradually drops as the capacitor discharges. And then in this part here, the capacitor is charging again, and we gradually then drop again. So we get what's called a ripple voltage, which is just the difference between the normal peak and the lowest point when the capacitor is discharging. Now the thing to remember is that a diode has a threshold voltage of when it will allow current to pass through it, if you remember. So this is completely arbitrary that I've put this on this line. I just wanted to give you the idea. So for our supply, when our diode reaches the threshold voltage, when the supply voltage reaches the threshold voltage of the diode, then our capacitor will start to charge and will be charging through this section here where the current is positive. As soon as the current starts to drop, our capacitor will start to discharge, and that means therefore that we end up with more of a supply than we would if we just used a single diode to rectify our input. And once again, once the input supply is above the threshold, in this part here, our capacitor will charge again and then discharge in the circuit. So we end up with a much smoother supply rather than something that looks like a bit like messy. Okay. So if we want to know what this ripple voltage is, well, ultimately it's going to be V0. Remember, that was our peak voltage from this particular diagram down here. V0 minus however much the capacitor has discharged during the time T between the voltage falling negative and the point here. So we know, therefore, we can rearrange this. V ripple is V0 1 minus e to the minus t over RC. And when t is much larger than RC, so the time constant, this equation will equate to V ripple equals V0 times t, which is the time period, over RC. But the thing to note is that you really want your time period of your system to be more than your time constant. Sorry, I'm getting my words muddled up. Because if you think about it, the time constant is defined as the time for the voltage to reduce to 37% of its original value. Well, we don't want it to have dropped that much. If I go in this time here, before we've got our positive supply, which is increasing and charging our capacitor again. So in this time here, we do not want to have reduced our output to 37%. So therefore, what we find is if we use this equation here, we can, knowing the frequency and therefore the time period of our supply, we can calculate an appropriate time constant, so we'll know an appropriate, or we can choose an appropriate value of resistor and capacitor in order to be able to keep the ripple voltage effect to a specific level within the tolerance of our equipment. So I hope that's helped a little bit. It's more of an extension task, but it's good to be able to understand how capacitors are used.